So, hello students of CISST Department, M.Sc Bioinformatics, Semester 2. This is Jai Mehta from Department of Mathematics, Sardar Patel University. I hope you all remember me. We are discussing mathematics of your course. So, before the lockdown, we had finished graph theory and matrices part was remaining. I had already provided you material and also made one video lecture which I posted on YouTube. I hope you received the link of the lecture. So after that, I did not post any other lectures or create any other lectures for mainly two reasons. First, I had already provided you the PDF file of the material with all solutions and exercises. Second, I did not hear any feedback from you, so I thought you may be preparing from the material itself. You did not refer to the videos. And third reason also is that the lockdown was uncertain, so we did not know how much time was there, whether exam will be taken or not, when the exam will be taken or not. So I thought you might not be interested in studying at that time based on the situation during that time. But now since the exams are due in just couple of weeks, I am making one more video and we'll continue with the matrices part. So what we have already discussed is, if you recall my video on YouTube, I had discussed what are matrices, some special type of matrices, definition and all, examples, transpose and addition of matrices. So these two operations, how to take a transpose, we just turn row into columns. So that is one thing which we have discussed. And addition of matrices, if two matrices have the same order, they are of the same order, then we can add two matrices but just by adding the corresponding entries. If you do not remember it, you can just refer to that video of mine. And another operation which is multiplication of a matrix by a scalar. For example, this is a matrix. If I want to multiply by some constant number, say 5, then each entries are multiplied by 5. So this is already we have discussed. So now three things are remaining. One is multiplication of matrices, determinant of matrices, and inverse of a matrix. So in this video, let me discuss multiplication of matrices. So this is my notes which I already given to you. So let me write here. So how do we multiply two matrices? So for multiplication of matrices, let us consider, suppose A is a matrix. In short, we write Aij and M cross N. You remember this is the number of rows, these are the number of columns, and B is also a matrix and it is Bij. So in short, we write Bij. When we write a big matrix, we write all the entries. So this is, suppose, N cross R matrix. So there are two matrices, Aij and Bij. What is the product? The product, suppose AB, we denote this by C, and the entries we write like Cij. And so what is the order of this matrix? So order of this matrix will be, it will be M cross R. M cross R. And how do we define all these entries? It's just a formula which you might find difficult to understand right now, but when we see examples, it will be very clear. So you can see already from this. So Cij is given by this formula. So suppose C is the multiplication of these two matrices. So it is nothing but summation I equals to so it is summation k equals to 1 to n aik bkj, and it can be written in expanded form like this: summation k equals to 1 to n aik bkj. So that is k equals to 1. So if I take k equals to 1, ai1 b1j, plus if I take k equals to 2, ai2 b2j, plus and so on. Lastly, k equals to, we'll have n, so ain bnj. And that is why you see it is important that we have this same n. Here n. So this n must be same as this. Then only we can multiply these two matrices. That means the number of columns, the columns of A must be same as the number of rows of B. So if the columns of A is same as the rows of B, then we have AB. So that is already it is expressed here. This is a material given to you. You can also refer that. So observe that the multiplication of this matrix AB is defined even only if this condition is satisfied. Number of columns of A equals to number of rows of B. Similarly, BA, if you want to multiply B with A, then number of columns of B must be same as number of columns of A. So let us consider this example. How do we multiply? So let me just write and show you. So A is 1, 2, 3, 2, 4, 1. So let me write. Let me clear this. So A is first row of A is 1, 2, 3. You already have this in the notes, but I am just writing here 2, 4, 1. And B is, so B is 1, 2, 1, 0, 0, 3, 1, 0, 4. 1, 2, 1, 0, 0, 3 and 1, 0, 4. Right? So first we multiply AB. Let us see by an example how do we multiply two matrices AB. For that we need first condition. So let us write the order. What is the order? How many rows are there? There are 2 rows. So 2 rows. How many columns are there? 1, 2 and 3. So there are 3 columns. And what is the order? This is a square matrix. Number of 3 rows and 3 columns. So same rows and same columns. So this is a 3 cross 3 matrix. And you can observe that the number of columns and the number of rows, the number of columns of A and the number of rows of B, they are same. So we can multiply AB. And what will be the matrix AB? Resultant matrix AB will have, what will be the order of this? Order will be this. This will be 2 cross the remaining. So order will be 2 cross 3. So order of AB is 2 cross 3, as we will find out. So order of A is 2 cross 3, order of B is 3 cross 3. And as I said, if you want to multiply A with B, the last part of A, that is the number of columns of A, must be same as number of rows of B. And then the resultant matrix AB, that will be nothing but will be of this order, 2 cross 3. Right? So the product will be 2 cross 3. And however, the matrix BA is not possible. The product BA is not possible. Why BA is not possible? Because B is a 3 cross 3 matrix and A is a 2 cross 3 matrix. BA is not possible because the problem, the number of columns of B is 3, number of rows of A is 2, and this does not match. So BA is not possible. So it may be possible two matrices can be multiplied only on one side. I mean A on the left and B on the right, but the other way is not possible. So BA is not possible. If only this is matching, then we can multiply B with A. So right now this is matching, so we can multiply A with B. And let us understand by an example how to multiply A with B. So A will be a 2 cross 3 matrix, and let us sorry. So now we multiply these two matrices A with B. So the resultant matrix, how do we multiply? AB. So Aij, Aik, Bkj, Ai1 and B. So the first entry of this and the first entry of this. Right? So we go from, on the matrix A we go row wise, and on the matrix we go column wise. So what we do is 1 into 1. So this is 1 into 1. first entry of this, first entry of this. Then by the formula, you can see the formula here, we have seen already. Sorry, yeah, the formula here, AIK BKJ. So AI1 and B1J. So here rows are increasing, AI2, so second entry and then the column. So this is how we multiply. So 1 into 1 plus, there was summation, you remember, you can see in the material, 2 into 0. So plus 2 into 0 plus still third entry of this and third entry of this. So here we go row wise, here we go column wise. So 3 into 1. That is why this condition is necessary. So there are 3 columns here. So how many entries will be there? 1, 2 and 3. And how many rows here? 3 rows. So how many entries? 1, 2 and 3. Here 1, 2 and 3. 1, 2, 3. And here rows 1, 2, 3. So that they match, and that's why we can multiply like this. First entry of this, first entry of this. 1 into 1, 1 plus 2 into 0 plus 3 into 1. So this is just the first entry. And now the second entry. How do we write the second entry? So first row here. Now second column. So 1 into 2. 1 into 2. Then 2 into 0. So we here the same row, but now here second column we take plus 2 into 0 plus third entry of this and now third entry of this. So 3 into 0. So this is just one entry. And now first row, third entry. So first row, third entry, we take first row of A and third column of B. So 1 into 1 plus second entry 2 into 3 plus third entry of the row and third entry of this third column of the first row. So 3 into 4. Okay, so this is just the first row. First row of A with first column of B. We multiply entry wise and take their sum. That is just one entry. First row of A and second column of B. We take again multiply entry wise and take their sum. That is just the second entry. Now what about the first row, third entry? So first row of this, and because it is third entry, so third column of B. So 1 into 1, then 2 into 3 plus 3 into 4. So this is the first row. And now let us compute the second row. So for second row, we use the second row of A. And how do we get all these 3 entries? Now use the second row and then first column, second column, third column each time to get each entries. So what will be this entry? Second row. So 2 into 1. 2 into 1 plus second entry of this 4 into 0. Here we go row wise on the right, from left to right. Here we go from top to bottom. So 4 into 0 plus 1 into 1. Right? So this is the second row, first entry. Second row corresponds to the second row of A, and the first entry corresponds to the first column of B. Now second row, second entry. So second row of this and second column of this. So again 2 into 2 plus 4 into 0. I hope I'm not going too fast. Plus 1 into 0. Okay, so now last, second row, third entry. So second row of this, third entry. So that is the third column of this. So how do we do this? 2 into 1. So this entry. This is 2. This is 1. And then plus 4 into 3. So here we go. This is 4 into 3. And then plus 1 into 4. Okay, so how many rows are there? 1 and 2. So 2 rows. And how many columns? 3 columns. So the resultant will be 2 rows, 3 columns. So we have got 2 rows, 3 columns. So now just we simplify this. We add this and get the final matrix. So this is 1 plus 2 into 0, so 0. You have to practice this to be good in calculations. 3 into 1 is 3. 1 into 2 is 2 plus 0 plus 0. Then 1 plus 2 into 3, 6 plus 3 into 4, 12. This is first row. 2 into 1, so 2 plus 4 into 0, 0 plus 1 into 1, 1. 2 into 2, 4 plus this is 0, this is 0, so 2 times 0. 2 into 1, so 2 plus 4 into 3, 12 plus 4 into 1, so this is 4. Okay, so what is the final matrix? So this is 1 plus 3, so that is 4. This is 2 plus 0 plus 0, so 2. This is 6 plus 12, 18 and 1. So this is 19. So this is the first row. And now the second row, 2 plus 1, so 3. 4 plus 0 plus 0, so 4. 2 plus 12, 14, 14 and 4, 18. So this is the matrix AB. So now let us check whether we have got this correct or not. Yes, so this is 1 into 1, 1, then 2 into 0, I have written directly. So 4, 2, 19, 3, 4, 18. Let us see our answer. 4, 2, 19, 3, 4, 18. Yes, full marks. So we have got the product AB, right? Now you can practice one more example if you want, and if you want I can make one more video if you need. So when we say that two matrices commute means AB equals to BA, then we say that A and B commute with each other, or A commutes with B and B commutes with A, or A and B commutes with each other if AB equals to BA. This only we can talk when we know that AB and BA both product are possible. For example, in the previous example, only AB was possible, BA was not possible, right? Because this condition was not satisfied. Number of columns of B is not equals to number of rows of A. So suppose in certain cases, if there are, so for example, square matrices AB, and so square matrices AB is also possible, BA is also possible. So suppose both are possible, uh, we say that A and B commute if AB equals to BA. It seems that they will be always equal, but that is not the case. So if I take identity matrix n cross n, identity matrix, all diagonal entries 1, other entries 0, into A, I get A. So this you can verify. And as I said, in general, matrix multiplication is not commutative. First of all, it may not be defined. AB and BA both might not be defined. But suppose both are defined, both are possible, both product, they may not be equal. For example, consider this matrices. So A equals to 1, 1, 0, 0, and B equals to 1, 0, 1, 0. So let us compute AB. So let me remove this. And so what is A? A equals to 1, 1, 0, 0, and B equals to 1, 0, 1, 0. So this AB. So A is a 2 cross 2 matrix. It's a square matrix. B is also 2 cross 2 matrix. So for AB, we have to check number of columns of A must match with the number of rows of B. They are matching. So AB is possible, right? So AB is possible. Let us compute AB. AB. So here we go row wise, here we go column wise. 1 into 1 plus this one into this one. Okay. So now this is the first entry. Now second entry. 1 into second, so 0. 1 into 0 plus again this one into this 0. Next 0 into 1, second row, plus this 0 into 1. This anyway row is 0, so everything is going to be 0. 0 into 0 plus 0 into 0. So AB is again 2 cross 2 matrix. Resultant matrix is 2 cross 2. If these two are same, the resultant matrix is this times this by this. Yeah, so let us compute. So this is 2, 1 plus 1, 2. 1 into 0, 1 into 0, so this is 0. This is 0 into 1, 0 into 1, so this is 0. All are 0, so this is 0. So AB is this matrix. Now let us compute BA. So for BA, it is always better to write B first, so that we don't make mistake, because now for BA we have to go row of B and column of A. So it will be just reverse direction. So better to write B first. So 1 0 1 0 is a 2 cross 2 matrix, and A is 1 1 0 0. So this is also 2 cross 2 matrix. So now we have written B first, and now we multiply what is we determine the product BA. So what is BA? So rows of B. So this again you observe these two are equal. Square matrices, so anyway they are equal. So resultant matrix will be another 2 cross 2 matrix. So order will be same. This is also 2 cross 2. BA is also going to be a 2 cross 2 matrix. So that means we can compare these two matrices. They have the same order. But will they have the same entries as well? Let us find out. So rows of B, 1 into 1. This 1 into 1 plus second here 0 into this second entry, 0 into 0. Okay, so this is the first entry. Now the second, so 1 into 1 plus 0 into the 0. Now for the second row, take second row of B, second row of the previous left hand side matrix and the columns of the right hand side matrix. So 1 into 1 plus this 0 into 0. 1 into 1 plus 0 into 0. So this is also 2 cross 2 matrix, and let us find out what is this. So this is 1 plus 0, that is 1, 1 plus 0, that is 1, 1 plus 0, that is 1, and 1 plus 0, that is 1. So you can see this is BA and this is AB, and these two matrices, they are not same. All the four entries are different. We can say that two matrices are not same even if one entry is not same. So clearly what we have here in this case, AB is not equals to BA. So both product are possible. A into B is also possible. B into A is also possible. AB and BA both are possible. Both have the same order, 2 cross 2, but they are not equal. So in general, matrix multiplication is not commutative. Commutative means AB equals to BA. So let us find out whether we have got correct answers or not. So AB is 2000, and these are all entries 1. So we have got this 2000 and all entries 1. Right? So in general, AB is not equals to BA. So next topic is determinant, which I will explain in my next video lecture if you want. If you already know and you are comfortable, want to prepare from the notes, it's okay. But do let me know if you want any further video lectures. So next two topics are remaining. One is determinant and adjoint, and then finally how to find inverse of a matrix. And besides this, even if you have any doubt in graph theory, you want me to take any video lecture, not like this, but interactive lecture on Zoom or Google Meet, then also you can inform me via Kirtan sir. You have my number also. I think one of you has my number. So inform me and prepare well for the exams. All the best. Thank you.